Welcome to Mr. Brown's Basement, a channel devoted to sharing the craft of repairing, restoring, and modifying vintage electronic gear, and other random stuff.
Welcome to another episode of Mr. Brown's Basement. This one is about a Simon game from the 1970s. I was told that this game works, but it doesn't. I put the batteries in and turned it on and nothing. So I pressed the start button and it made a tone, but there were no lights. That means there is something very wrong. These aren't terribly complicated things, so let's take a look inside. First, I'm going to have to remove these two switches and the screws, and it all comes apart. This is the inside of the Simon game, and what you see, a bunch of switches, some slide switches, and two integrated circuits, and 4 bulbs. Not much else. So one of these chips is MB4850, and this chip is SN7991. That's not the right number.
Texas Instruments SN75494N.
And that's about it. So what I've learned from researching this device is that one of these ICs is a driver, and the other is a very rudimentary microprocessor. But let's see what's wrong. Let's check out these bulbs. These bulbs are rather unusual. They're wedge base, and what's also unusual is that in early versions like this, there's a spare bulb. But let's just take out all the bulbs and test them. Put my ohmmeter on the lowest scale and connected it up to the bulb, and it's an infinite number of ohms. In other words, open circuit or a dead bulb. And in fact, I've tested all 4 of these bulbs, and they're all dead. And that's very weird. Let me show you what a good bulb would look like. Here's the good bulb connected up, and 4.1 ohms. Cold resistance, in other words, a low resistance because current is going through the filament. It's unusual that all 4 of the other bulbs would be dead. It's hard to see, but this is a GE127 bulb. You can look it up. It's like a 2.3 volt bulb, fairly low current. It doesn't really matter what color bead is inside. It used to matter, it doesn't matter anymore. I've got 4 new bulbs installed. These are from Mouser Electronics, and we're going to test it. All 4 lights are illuminating, which isn't right, especially when the switch is off. When I turn it on and push start, I get a tone. Okay, the game is going, but the lights are all staying on. Again, the game is still going, but the lights are all staying on. So let's take a look at the schematic. This is very interesting. The on-off switch only turns on and off the 9-volt battery. The 3-volt supply is unswitched, so it's always on. And it's actually going to this other chip, and it does all the switching. So that tells the bulbs to be off, and the fact that they're all on means that that chip is not telling them to be off when they should be off. So that chip, at the very least, is messed up. So let's replace it. There it is. That's my suspect. What I'm going to do is pull out the old one and put in a socket, because I can. And hopefully I have a 75 494. That's what it is. 75 494 or equivalent. The printed circuit board and the speaker came out of the case really easily. Just 2 screws to hold in the printed circuit and a catch that holds in the speaker. Remarkably good quality. It is a genuine Milton Bradley, that's MB, and it's a Rev C. So I'm going to turn on the soldering iron and see about taking out the right chip. I don't want to take out the wrong chip. That would be very stupid. Here's a 16-pin dip socket, but I don't have any 75 494s. I do have an equivalent. They're Russian, KM1010 KT1. These haven't been made in a very long time, and I guess they're getting a little scarce. To desolder, I'm going to use a solder sucker gun. What it does is it heats the thing that you want to desolder with this, and then you hit the trigger, and then it activates this plunger and sucks all the solder out, the molten solder, into that cylinder. And that's the chip right there. The one with 2 unused pins. After about 2 minutes, the chip is out. Almost as easy as it looks in the ads for these solder sucker guns. Almost. And doesn't hurt the printed circuit at all. So next I put in the socket, making sure, you see pin 1, making sure that I have the socket in the right way, so I put the chip in the right way, and I should be off to the races. Now while I'm waiting for my soldering iron to warm up, I'm going to go back to the diagram and think about why this problem exists. Now, integrated circuits are notoriously unhappy about being connected up with reverse polarity. I'm thinking that perhaps the previous owner might have put the batteries in backwards. You see the 3 volts on pin 16 and ground to pin 8. The bulbs were probably working at the time, and they provided a low resistance path and killed the IC. Now, maybe I can do something to prevent that from happening in the future. But right now, let's get back to soldering in the new chip and seeing if that makes a difference. The new IC socket has been soldered in place. There are no solder bridges between the pins. And now it's a matter of plugging in the new IC. I've got tape on the 9-volt battery because the clips are really sad. I should probably replace them. Yeah. And I'm going to turn on the power. 3 volts. 3 volts. None of the LEDs are lighting. That's a good sign. Let's turn it on. Push start. And nothing. Well, that's weird. 3 volts is getting to the board. Yep, 3.0. Oh, and no current. Yeah, that's good. Perhaps my 9-volt battery isn't good. It's not doing anything now. But I have a funny feeling that's because there is a difference between the real 75 494 and this Russian equivalent. According to the specifications on this chip, VSS pin 1 has to be connected to the most positive part of the circuit. And looking at this, pin 1, where is it? There it is disconnected. So I'm going to bridge pin 1 with the most positive part of the circuit, which is plus 3 volts, and see if that makes a difference. I've got this nut pick connected to 3 volts, and I'm touching pin 1. I'm going to turn it on. Okay, I've got the nut pick connected to pin 1 and to plus 3. It's on, and now I'm going to use, I don't know what I'm going to use. I'm going to take my hand off the camera and press the start button. Something's happening. I'm getting sound. Let's try starting again. Well, I think I have an answer. I'm going to make that permanent with VSS connected to plus 3. There we have it. A jumper from pin 1 to pin 16. Pin 16 is VCC, which is plus 3 volts, the highest place in the circuit, so that should do it. Here goes. I'm going to turn on the circuit. I'm going to press start. All right, it does actually work. The next step will be to replace the 9-volt battery clip and think about how to prevent this from happening again. Solution 1. Put a diode into the circuit. Good idea, it's simple, but I'll lose 0.6 of a volt across that diode when it's forward biased if it's a silicon diode, or 0.3 if it's a Schottky diode. But unfortunately, I don't think I can do that because of the way the printed circuit board mounts into the case. These pads connect directly to the battery container, so I don't think I can stick a diode in series. Solution 2 would be to put a diode across the batteries. That would be fairly easy to do. And if the batteries were put in backwards, they'd simply be short-circuited and would die, possibly leak. Solution 2A would be to do the same thing as solution 2, except add a PTC fuse, essentially a thermistor, that when it gets hot increases resistance. And that would mean that if the batteries were connected in backwards, no current would end up flowing because the PTC fuse would turn off the short circuit. But again, like with solution 1, I may not be able to put a fuse in between the board and the battery compartment. Here's my solution. It's a hybrid solution. A 1N4007 diode that will pass the current if the batteries are put in backwards, and that symbol and that symbol inside the battery container, which really should have been in the battery container, not just that. And hopefully that's enough to prevent anybody from installing the batteries in backwards. I'm sure that's what killed the IC. I think this is done. Maybe I'm going to be sorry I fixed it. Yeah, I'm already sorry. Thank you for watching this video from Mr. Brown's basement. I hope you enjoyed it. That's all for today. Please consider clicking the thumbs up button if you enjoyed it, and maybe even subscribing to this channel so that you're notified when other interesting videos come out.
Thanks for watching.